Hello, and welcome to Team 5's Deep Learning project on using Allosaurus for speech emotion recognition. So for a quick introduction, speech is the most natural way of expressing ourselves, and so it's only natural then to extend this communication medium to computer applications. In this project, we show the task of speech emotion recognition as a collection of methodologies that process and aims to classify speech signals to detect the embedded emotions. Previous application domains and research within speech emotion recognition has shown many beneficial applications which need human-computer interaction, such as speech synthesis, customer service, education, forensics, and even medical analysis. This task has been solved before using common feature extraction methods based on the spectrogram of utterances. However, in our project, we present a novel approach using Allosaurus as our feature extractor to see how performance matches with state-of-the-art results. This project aims to build upon Allosaurus, a multilingual acoustic recognition model, which considers the relationship between phones and phonemes to construct a speech emotion recognition system.
There are several outstanding approaches already, but we're mainly using a novel approach that uses Allosaurus as a data pre-processing tool, which we'll get to later, to generate either phonetic transcription or embeddings. Once we have it, we feed it to the neural nets. So basically, we use two data sets, the IM cap consisting of English audio and the SDD, which is a Greek. Since we're comparing the result with the state-of-the-art method from a recent paper, which only experiments with 4 classes, angry, sad, happy, and neutral, we truncated the IM cap with only data consisting of those 4 emotions. We assume that those 2 data sets are commonly used in current state-of-the-art methods in their language domain.
The core component of our work involves using Allosaurus as an initial feature extractor. As seen in the figure in the left, the Allosaurus model works by first computing the phone distribution using a standard ASR encoder, and then the allophone layer maps this distribution into phonetic transcriptions for each language. Our work involves using the universal embeddings and the language-specific phones from Allosaurus as features for the downstream deep learning models. While the current work focuses on the English and Greek language domains, since Allosaurus is a universal phone recognizer, the work can be extended to any language. We follow previous state-of-the-art work and use a CNN LSTM architecture followed by a fully connected layer for the final classification output. We also use a pure LSTM and a pure CNN architecture as baseline models. We run the entire pipeline seen in the figure for all 3 models with both the phonetic transcriptions and the embeddings for a comparative study. In general, we do expect the embeddings to perform better across language domains as they are essentially low-level feature representations of the utterances.
These are the results we obtain on different neural network architectures. They include both the embedding-based approach and the phonetic transcription-based approach, and the best of our results from the limited grid search we could conduct. Our comparison benchmark, which is also state-of-the-art on the EmoCap dataset, is the temporal context-based wave-to-wake approach. From this plot, we can see that our best performing model is the embedding-based pure CNN model, and our poorest performing model is the phonetic transcription-based CNN plus LSTM. This is expected because speech emotion recognition works poorly on phonetic transcriptions, as phonemes directly do not capture any information about emotions. Even though our model does not beat state-of-the-art on EmoCap dataset, using embeddings from Allosaurus, it performs extremely well on the out-of-the-domain dataset.
In conclusion, the results on test accuracy showed a promising approach using the Allosaurus as a feature extraction method, especially in extending to out-of-domain languages other than English, such as Greek. However, due to lack of time and resources, we will only be able to coarse tune our hyperparameters, and the grid search that we did was limited to 12 of configs. Also, we were not able to try different folds of cross-validation. Additionally, further fine-tune of the internal structure of Allosaurus is needed to better fit the task of speech emotion recognition. Thank you for listening.